Hi everyone, welcome to Narrated Solution number 2. Revolve the region bounded by y equals 6 minus 2x minus x squared and y equals x plus 6 about the line y equals 3 using vertical rectangles. Okay, so it says about the line y equals 3. So this is the exact same kind of problem as the one above, right? We're using the same function here. We're using the same function here as we did in Narrated Solution number 1, right? And we're still using vertical rectangles. However, now we are rotating about the line y equals 3. And I'll show you how that kind of changes things a little bit, okay? So pause the video, copy down these sketches, and let's hit it. Okay, hey, welcome back. So this problem, again, like I just said, is the same as the previous washer problem, but I want you to take note of one major difference, right? So instead of revolving our representative rectangles around the x or y axis to generate a solid, we are now rotating our representative rectangles around the line y equals 3. This doesn't change much about the solid's appearance, as you'll note here, but it will change the measurements of the inner and outer radii, and here's why. So in the outer function, well, first, actually, let's talk about the outer function and what its radius would look like. So in the outer function, that's going to be our 6 minus, I'm sorry, there's work going on in our basement. Okay, so in the outer function, we have 6 minus 2x minus x squared. That will yield our outer radius. However, we are going to need to remove a space that is 3 units tall from the function and the axis of revolution. So just like you see that we are revolving around the horizontal line y equals 3, we're going to have to subtract that 3 to account for that space at the end of our function to generate the outer radius. We're going to do the same for our inner function to generate the inner radius. So our inner function is going to be x plus 6, but then we have to account for the fact that there is a space now 3 units tall between the function and the axis of revolution. So we are going to have to go ahead and subtract 3 from that guy too. So now we are going to set up our increment of volume. So we are going to approximate the volume of one washer, and then we are going to add up all those slices, and then we are going to set up our definite integral. So in our washer right here, we have our outer function, or our outer radius, and that's going to be given by, I'm just going to combine terms up here, right? So I am going to get 6 minus 3, which is going to be 3 minus 2x minus x squared. And then our inner radius, is going to be generated by the function x plus 3. Okay, so now let's set up our increment of volume. Now we are going to set it up. So the volume of one of these washers is going to be the pi times outer radius 3 minus 2x minus x squared minus the inner radius, which is going to be x plus 3 squared. And then we're going to tack on our delta. Whoa. X at the end. Let's see. That is our increment of volume. And then now we are going to set up our Riemann sum, where we add up all these washers and see if we can approximate a volume. We've got pi out front, and we are starting when the number of washers is 1 and going all the way up until we have n washers. And I'm going to go ahead and expand this 3 minus 2x minus x squared squared. I'm going to expand the x plus 3 squared, and then I'm going to combine like terms, and that will give me, oh, I forgot the little i's down here, sorry. xi to the 4th plus 4xi to the 3rd minus 3xi squared minus 18xi delta x. So that is going to be our Riemann sum. Now, as we let n, or the number of washers, approach infinity, we will get our definite integral that will yield the exact volume of the solid of revolution, and that will be x to the fourth plus 4x cubed minus 3x squared minus 18x dx. And go ahead and pause the video and get the solution and then match it with mine. Sorry, that's an 8. Okay.